This video shows you how to use a circular saw, how to select your blade and the dust extraction, as well as health and safety tips and how to make diagonal cuts on plywood. And here, the power tool that we've got is the Gullet 1400 watts 185mm circular saw. The table saw is at the very core or epicenter of the woodworking shop. And at the very core of your table saw is your blade selection. Suffice to say, the blade selection is crucial or pertinent with regards to getting quality cuts. And so the big question is, why have we opted for a circular saw? Firstly, a circular saw is handheld, whereas, a table saw is stationary, it lays flat. The, circular saw is budget friendly. The table saw is slightly more expensive. You can make fewer cuts when using the circular saw, but with the table saw, you can make more accurate cuts. It's quite messy when you're using, the circular saw, with sawdust, but, the table saw tends to be a lot more cleaner. If blade selection is pertinent or at the very core of getting quality cuts, then we must be able to decipher or interpret technical data that is associated with the cutting blade. Technical data or jargon isn't as daunting as it seems once you get the hang of it. For the Gullet power tool, we've got a blade size of 185mm, a blade bore at 20mm. It's got a cutting capacity of 90 degrees at 65mm and 45 degrees at 45mm. So it essentially means, it can cut at various angles up to a depth of 65mm or 45mm, depending on the angle. And also a bevel capacity that's capable of doing cuts, from anywhere between 0 to 45 degrees. So it could be 0, 15, 30 and 45 degree cuts, okay? At a later stage, I will be showing you how to set, the depth that you want to cut and the angle at which you want to cut, okay? But first, let's get conversant with all of this data. If you juxtapose the technical data information side by side with the information that you've actually got on your blade, we can instantly begin to see that there is a correlation. 185 being the actual blade size or the size of the rim, 20mm being the blade bore, which is right at the center of the blade, and 2.4mm is the thickness or kerf of the blade. At a later stage, I will show you how to adjust your cutting and bevel capacity. The next step would be to familiarize with other work tool components. When I push on the lower guard lever clockwise through the fixed guard, it reveals the bottom of the blade, and you can see that it is being rotated in the direction of both arrows earlier highlighted in the aforementioned. To change your saw blade, you need to take out the blade bolt and the outer flange with an Allen key, which then reveals the blade bore, the saw blade, and an inner flange behind it. Just remember that when fitting in a new blade, that the saw blade must be sat on the inner flange, okay? Suffice to say, the saw blade must be sandwiched between the inner and outer flange, with the blade bolt coupled onto the outer flange, okay? The tip of one tooth to the tip of the next tooth is called the step, while the gullet is the space in front of each tooth. Just take cognizance of the gullet, the size and its depth determines how much wood can be removed during cutting. In general, if a saw blade has fewer teeth, the speed rate will be faster and it will have a larger gullet size. And larger gullet sizes are most suited to rippling applications. But if you've got more teeth and smaller gullet sizes, then it's more suited to cross-cut applications. I'll show you what I mean in a minute, okay? Economy blades almost always have a thin stamped steel plate with expansion slots that end bluntly in open holes, which is what we've got here. The open hole exudes or signals old technology, and a noisy blade, whereas good quality blades have a laser cut plate, as you can see here, and the length and width of each tooth tip is bigger. than the economy blades. The laser cut blades are designed for long life and the teeth can be resharpened many times. Here we have got an economy cross-cut saw blade, and you can tell by its stamped plate, open technology and fewer teeth, with a very small gullet or space between each teeth. And if we zoom out, the stamped caveat highlights that the saw blade rim size is 8.5 inches, the center bore 30mm, it's got a 40 teeth, and the kerf thickness is about 2.4mm with an RPM of 7,000. So cutting or ripping applications is dependent on the gullet size and the number of teeth that you've got. But the number of teeth does not determine the quality of the cut or the purpose. Even though you may have often heard that you'd get smoother or finer cuts with a cross-cut blade and a rougher cut with a ripping blade. To get good quality cuts, you need a blade to do the job that you're doing. Here we've got a plywood strip that's been stripped off the plywood board, and you can tell by the layers, on the side. And so although you need a ripping blade to cut wood vertically along the grain of the wood, and a cross-cutting blade to cut across the grain of the wood horizontally, you might be tempted to think that getting a cross-cut blade to cut across the grain of both the strip and the plywood would be the best blade to get. And you might also be tempted to think that getting a ripping blade to cut along the grain of the wood vertically would be the best blade to get, when cutting the plywood strip and, the plywood board. But both the ripping blade and the cross-cut blade as standalones may not be the best solution to cut your plywood, as your plywood is a type of manufactured wood panel that's made by gluing veneers together. And as a result, there is that high propensity that the wood grain may be alternating on each other. If the veneer layers are glued with the wood grain of the plies at right angles to each other, suffice to say, when you're dealing with your plywood, the grain isn't homogeneous or uniform along the grain of the wood and across the grain of the wood, as there is a crossover of ripped grains and cross-cut grains. So using a dedicated rip blade or a cross-cut blade would not be the optimum solution to get quality cuts. You would be better off using a combination blade which has got about 40 to 50 teeth, or a general purpose blade. They don't rip as good as a dedicated ripping blade, or they don't cross-cut as good as a dedicated cross-cutting blade, but they do an adequate, pretty good job of both. Combination and your general purpose blades are anywhere between 40 to 50 teeth. This combination blade has got big gullets and in between fine tooth. Both the general purpose and the combination blade can serve as your optimum blade. If you find it laborious to change a blade, it gives you the added advantage of leaving one blade in your work tool. This is a quality tool as it's got laser cut expansion holes, which reduce noise and vibration, big ripping gullets, and fine cross-cut teeth, and extra large carbide teeth that allow multiple resharpening. So, do you choose a combination blade or a general purpose blade to get quality cuts off of plywood? The answer depends on the purpose, the woodworking that you do, and typically the type of material that you work with. Both of these saw blades fit the jack of all trade types. Suffice to say, an all-in-one blade for all cuts. This general purpose saw blade has also got a laser cut steel body. It is made of cold rolled steel and an extra thick carbide teeth that can take a sharper edge, stay sharp longer, and can be resharpened multiple times than most blades on the market. Both the combination and the general purpose have both got a chrome armor plating instead of painting, which helps with aesthetics, corrosion resistance, ease of cleaning, durability, and lubricity. The 40 tooth saw blade with a 30-degree alternate top bevel grind tooth configuration easily rips off hardwoods up to 1 inch thick and excels at cross-cutting hardwoods and veneered plywoods. It's also got, a resin filled vibration dampening slots that helps to reduce harmonic vibration, and an extremely clean cut, tantamount or almost mimicking the extremely clean cut that you'd get from an 80 tooth cross-cutting saw blade. So what can we take from this? If you take a more incisive look and examine all manufactured boards, whether it be composite boards or man-made boards like your plywood, chipboards, or medium density fiber boards, you will quickly come to the realization that their grain structure is haphazard or sporadic with respect to its grain structure, line of travel, orientation. As you can see, in this case, your plywood veneers, overlap or overlay each other. They go in different ways, which essentially means that your veneer sheets are sat on top of each other, and so you do not have a grain structure as you're always ripping or cutting, when you're using your saw blade. That's why it is recommended that you can use a general purpose blade or a combination blade to cut your plywood, which have a range of 40 to 50 teeth, or you can use a composite blade with a range of 60 to 100 teeth. An increase in the amount of teeth essentially means that, it will take a bit of more time for you to cut through your plywood, but, it does, a bit of cutting, a bit of ripping, not as your dedicated cross-cut blades or your ripping blades. But you will get better quality cuts with the composite blades. So ideally, a composite blade with a 60 tooth threshold value should be able to get quality cuts off of the plywood. And so now let's move on to some more simpler woodworking. For cutting natural wood, or in this case pine wood, we can clearly see that the grain structure isn't overlapping. It isn't random or chaotic along the grain of the wood and across the grain of the wood. And so you will need a dedicated ripping blade to run or cut along the grain of the wood. The ripping blades typically have about 24 teeth. They have large gullets between each teeth to move out big chunks of wood. So it essentially cuts long fibres of wood or moves out big volumes of wood when cutting. So essentially, you need big gullets for reaping, to reap in the same direction as the grain to enable big chips come off the wood. If you cross-cut from the end grain with a reaping blade, you will only get tiny fibers off your wood. And that is because a dedicated ripping blade is not suited for cross-cutting. Do not use a rip blade to cut plywood, melamine or MDF. The quality of the cut will be poor with excessive tear out. Cross-cutting blades, on the other hand, typically have a 60 to 80 teeth range. And so with cross-cutting blades, you want a blade that can cut across the grain of the wood. As exemplified here, cross-cutting blades have fine tooth and more teeth with smaller gullets. So essentially, you're cutting across the grain to achieve a finer cut. Do not use a cross-cutting blade for reaping applications. And that's because if the gullet isn't big enough, it may not be able to excavate material from the gut, which leads to overheating. And so for reaping, you want to use 40 tooth or less, or typically 24 tooth. And for cross-cutting, 60 to 80 tooth. And so here is a quick overview of the saw blades and their tooth range. Saw blades have got distinct tooth geometry. If we isolate one tooth, you can see at the top of the tooth, the kerf or the thickness of the tooth, the bevel or slope, the face of the tooth, and the gullet. in front of each tooth, which can be different for different saw blades. For the alternate top bevel or ATB, you can see that the top isn't necessarily flat, but rather it is slopey and sharp and alternates to the left or to the right. Its teeth cut like knives and in effect scoring the wood to minimize tear out. And as you can see, the bevel angle varies. Increasing the bevel angle is tantamount to improving cut quality, but the durability reduces significantly. Your mundane ATB teeth are used on cross-cut, general purpose and some rip blades. To cut hardwood plywood, you're better off using an ATB whose bevel angles have been tilted to 30 or 40 degrees, steeply. At 30 or 40 degrees, they will cut melamine perfectly, without tearing the paper-thin face veneers. But like I said, the quality of cut is improved when you increase the steep bevel angles, but you compromise on durability. But like I said, your regular ATB are more durable but provide less quality cuts as opposed to your high angle alternate top bevel, which provide better quality cuts but are less durable due to the steep angles. And lastly, for the ATB, you've got your alternate top bevel raker. The ATB raker's tooth configuration consists of cross-cutting teeth and ripping teeth in 5 tooth clusters. It is designed for both ripping and cross-cutting, and it is featured on the 50 tooth combination blade like we've got here, where the caveat reads 50 teeth. The next tooth configuration geometry is the flat top grind teeth. They are used mainly on rip blades where a fast feed rate is important to prevent overheating and where bottom side tear out isn't an issue, as the cut runs parallel to the wood fibers or along the grain of the wood fiber. The next tooth configuration is the triple chip grind. They have beveled corners on either side of one tooth and then alternate with an FTG teeth continuously throughout the circumference perimeter of the blade. Suffice to say, on the blade, the beveled corners alternate with the FTG teeth. They don't have scoring bevels as in the case of the ATB, so the TCG is very durable and is used on glue line rip blades, blades for melamine board, laminate and other manufactured materials, where tooth durability is most important. The TCG geometry is particularly suited or designated for particle board products and abrasive materials, like your melamine and MDF. Melamine can be used as the litmus test or acid test in determining, good quality cuts from your TCG. Suffice to say, if you get good quality cuts from your plastic or plasticized melamine, then there is a high propensity or likelihood that you will get good quality cuts of your veneered plywood using your TCG tooth geometry. Good quality cuts from the TCG on the melamine will often result in, a fine smooth cut quality along the top edge of the melamine, which will have pristine sharp corners. Which is the pro. The con is, as the blade exits the bottom side of the melamine, it may chip off a little bit as it exits the plasticized bottom. Tooth hook, also called the rake, refers to the angle of the tooth face in relation to the center of your saw blade. Tooth with a positive hook cuts more aggressively. The rake or tooth hook for ripping blades is usually 20 degrees, whilst that of a typical all-purpose blade is between 15 to 20 degrees. The smaller the hook angle, the more pressure is required to feed your workpiece. Blades which have a zero rake or even still a negative rake are best suited for use on a radial arm saw. table saw, and miter saw because they prevent climb cutting and self-feeding. Sometimes you will find the hook angle caveats, labeled on your blades. In conclusion, your steep angle determines how steeply your tooth leans into the cut. So in choosing a saw blade, we've made the following considerations with respect to the application: the number of teeth, the gullet, the tooth configuration, and the tooth angle. Blades usually come in your conventional standard size 5.5, 6.5, and 7.25 inches, as well as other bespoke dedicated sizes from anywhere between 8.25 to about 10 inches. In this section, we will be reviewing 8 blades whose applications are for chipboards, composite materials, hardwood and softwood. This blade has got a 20mm bore, 9200 RPM. The rim size is 165mm or 6.5 inches and the kerf thickness is 1.8mm. It's got 24 teeth, which means it's particularly suited for ripping wood. It has latch gullet, so you'll be getting coarse cuts. It's got stamped caveats on its steel plate. It's got, the open expansion technology, which is the old technology, so it's going to be noisy. But you probably would be able to get the job done in no time, as, you'd probably get fast, coarse cuts, get long fibers off your wood. Along its grain, the next blade's rim size is 165mm or 6.5 inches. It's got a 20mm bore, 9200 RPM, a 2mm kerf and 40 teeth. It's got more teeth, but it is at the threshold for ripping, so it can be used for medium ripping and cross-cutting. It could either be a combination or general purpose blade, but there is no way of telling without opening up the packaging. You should get a fast cut, but will be noisy, as it is the old technology with open expansion slots. The next blade has got a slightly larger rim at 185mm or 7.25 in comparison to the blades 1 and blades 2. It's got a kerf of 2.2mm, 20 teeth and a 30mm bore with an 8200 RPM. 20 teeth denotes a ripping blade, and fast cut. I wouldn't be using this for medium ripping and cross cutting, but solely as a dedicated ripping blade. It's pretty much up to you. The next blade's rim size is 185mm or 7.25. It's got a 2mm kerf and a 20mm bore. It's got 36 teeth, which means it's got more teeth than your conventional 24T ripping blade. And the gullet here would be a lot more smaller. And again, it's closer to the lower limit threshold for combination or general purpose blades. So this blade should give fast cuts, and can be used for medium ripping and cross cutting. And you should have a more refined coarse cut finish. The blade on the inside could be a ripping blade with more teeth and a smaller gullet. The next blade has got a 210mm or 8.25 inch rim size, a 2.2mm kerf, a 7200 RPM and a 30mm bore. It's got 20 teeth, which connote a coarse cutting, and a ripping blade with large gullets. HS means high speed steel, and HW on all saw blades connote a robust tungsten carbide. For longevity and fast cutting, it's pretty much adept for all types of wood, laminates and plastic. The next blade has got a 210mm 8.25 inch size rim, a 2.2mm kerf, a 6500 RPM and a bore of 30mm with smaller gullets. Can be used for medium ripping and cross cutting, so I'd be more inclined to say this is a general purpose blade or a combo or combination blade. The next blade has got a 10 inch or 254mm sized rim, a 2.5mm kerf and a 30mm bore, 6000 RPM and 40 teeth, so could be a combo or a general purpose blade. The last blade has got a 250mm or a 10 inch sized rim approximately, a 2.8 kerf and a 30mm bore. an RPM of 6,080 teeth, which implies that you really could be getting a fine cut off from this blade with 80 teeth. It could be a general purpose, a combo or composite blade. And although all 8 blades are recommended for chipboards, composite materials, hard and soft wood, some blades are particularly more suited for natural wood and some for man-made manufactured boards. They have all got the open expansion slots and stamped steel, so they are noisy and economy blades. And so next we will be reviewing some DeWalt saw blades. We've got one 40 teeth saw blade and two 24 teeth saw blades, all of which have got a 216mm rim and a 30mm bore center. Each blade has got open expansion slots, so they're more prone to vibration, noise and blade warp. It is more probable that the 40 teeth is a combination or general purpose blade, as it's got, smaller gullets. And 40 teeth falls within the tooth configuration for a combination blade. The other 2 blades have got 24 teeth or fewer teeth, with larger gullets and maybe more suited for ripping applications. All 3 blades are economy blades. The combination blade may not rip or cross-cut as good as a dedicated ripping or cross-cut blade, but they will do a pretty good job of both. And like I said, the 40 teeth combo or general purpose blade is the optimum blade if you want to leave one blade, in your tool, as opposed to changing your blade every now and then, especially if you find it laborious to do so. Next, we're going to look at 5 Freud quality blades. This 24 teeth saw blade has got a 190mm rim diameter, a 2.4mm kerf and a 30mm bore. It's got a 15-degree bevel and a 15-degree hook or rake angle. The 15-degree positive hook or rake angle essentially means that the blade would cut more aggressively. The blade deploys a laser cut expansion slot, which essentially helps to reduce noise and vibration and also helps to prevent warp. The laser cut expansion slots are resin filled slots. The 24 teethed or tooth blade essentially means that it's more suited for ripping applications. But if we also take cognizance of the positive rake or hook angle at 15 degrees, it could also indicate that it is a general purpose blade, as the hook on a typical all-purpose blade is anywhere between 15 to 20 degrees. Whilst blades designed specifically for ripping applications are usually 20 degrees. So essentially, this is an all-purpose blade. You'd get great finishes for your ripping, and you can use to, cut along and across the grain of the wood, if you also want to cross-cut, okay? So it will do a pretty good job of both ripping and cross-cutting. But you might be better off using this as a ripping blade, as it's got larger gullets and can extend the application for cross-cutting, as it's got a positive rake or hook angle at 15 degrees. The blade teeth is made up of titanium carbide, which is extremely harder than your tungsten carbide. They tend to provide fast, no chip and perfect cuts. This blade is particularly suited for cutting along and across the grain of woods. The positive hook angle essentially means a faster feed and more pull on the blade, as opposed to a negative hook angle, which prevents climbing of the wood or self-feeding of the wood. It's also got a permashield incorporated, which withstands the toughest applications and provides thermal insulation. The permashield also helps to protect against corrosion and eliminates resin buildup, thus reducing downtime for cleaning. The next quality blade has got a 190mm rim size, a 30mm bore, a 2.4mm kerf and a 48 teeth blade. All them blades shown in this exposition have got the laser cut open expansion slots, or resin filled slots, which indicates that they are quality blades. as opposed to economy blades, which have got the open hole technology and stamped blades with small teeth. This quality blade has got bigger teeth or tooth sizes. It's got a hook or rake angle of 10 degrees, so it's not a very aggressive feed, as the smaller the hook angle, the more pressure is required to feed the workpiece. The previous blade has got a slightly more aggressive feed, as the hook angle was 15 degrees. Suffice to say, blades with a 0 or negative hook angle are better suited for your radial arm saws and miter saws because they prevent self-feeding or climb cutting. The blade type tooth configuration is an alternate top bevel, as the bevel tooth angle is 15 degrees. In general, an alternate top bevel tooth configuration, which falls within the range of 10 to 20 degrees typical, is an all-purpose ripping and cross-cutting blade. And so, if the bevel of this blade is 15 degrees, I would be inclined to say that this is an all-purpose ripping and cross-cutting blade, okay? Which can be used for medium ripping and cross-cutting. And that's because an optimum ripping blade has got about 24 teeth, whilst a cross-cutting blade is anywhere between 60 to 80 teeth. This quality blade has got 48 teeth, which means that, it does a moderately good job of, cross-cutting and ripping, but not optimally, okay? It's not, a designated blade, but rather a general purpose blade with small gullets. The third blade is an interesting one. It's got a 216mm rim size diameter, a 2.4mm kerf, and it's 24 teeth with a 30mm bore center. It's got a negative hook or rake angle of -5 degrees, which means it's perfect for table saws, radial arm saws, and miter saws, as the hook angle prevents self-feeding or climb cutting, which necessitates adding more pressure to feed the workpiece. The bevel tooth angle is 15 degrees, which falls within the alternate top bevel 10 to 20 degrees typical range. So this can be classed as an all-purpose or general purpose ripping and cross-cutting blade with large gullets. So just because it's got 24 teeth, it doesn't necessarily mean that it is a designated ripping blade. On the contrary, the bevel tooth angle at 15 degrees connotes that this is an all-purpose or general-purpose ripping and cutting blade. But if the blade type was a flat top grind with a tooth angle bevel configuration of 0 degrees, then it would have been more suited to say that this was a designated ripping blade, which would enable fast ripping and rough cross-cutting, but this is not the case, okay? This is a general purpose blade with an alternate top bevel tooth angle configuration of 15 degrees, which can be used for ripping and cross-cutting. The next blade has got a 250mm rim size, a hook or rake angle of 20 degrees, a bevel of 15 degrees, a 2.8mm kerf, and a 30mm center bore. So, at first glance, the 24 teeth suggest it is a ripping blade, but when you look, a little bit further, the bevel at 15 degrees suggests it is an all-purpose ripping and cross-cutting blade, but not so fast. The hook angle on a typical all-purpose blade is anywhere between 15 degrees to 20 degrees, whilst blades designed specifically for ripping are usually 20 degrees. With 24 teeth configuration, the hook angle on this blade is 20 degrees and it's got large gullet sizes, so I'd be more inclined to say that this is a ripping blade. And so, although the bevel is 15 degrees, which connotes a general purpose ripping and cross-cutting blade, I would be more inclined to use this as a ripping blade as you've got large gullet sizes, 24 teeth and a hook angle of 20 degrees. The next quality blade has got a 216mm rim size, a 2.4 Kerf, 48 teeth and a 30mm center bore, with a -5 hook angle and a bevel of 15 degrees. The negative hook angle connotes that this type of blade would preferably be used on a table saw, and the 15-degree bevel connotes an all-purpose ripping and cross-cutting blade with an alternate top bevel configuration. All of the 5 quality blades displayed are specifically for working wood, as you can see on the reverse of the label where wood is highlighted specifically for them blade types. And you can also see that all blade types and teeth are made from titanium carbide. So when selecting your blades, apart from the type of material that you're cutting, take cognizance of the gullet sizes, the number of teeth, the hook angle, the bevel, and what your blades are specifically designed for, in this case wood. So now let's take a look at some other designated dedicated blades, and here we've got the TCX15 Universal Turbo Segmented Diamond Blade and the TC10 Diamond Blade. The TCX15 is specifically recommended and designed for cutting concrete products and general building materials including bricks, blocks, pavers and concrete roof tiles, whilst the TC10 General Purpose Diamond Blade is also ideal for cutting curbs and slabs, bricks, concrete pavers and blocks, roof tiles and general building materials. So both the TC10 and the TCX15 are not specifically designed for cutting wood. At first glance, the blade in the circular saw working tool is an economy blade that can be used in cutting wood. It's got 30 teeth with large gullets. Blade installed in the Bosch working tool, which bears the trappings and hallmarks of a ripping blade. But we will be more definitive, in working out if it's a ripping blade once we assess, the bevel and the hook or rake angle. The next blade at quick glance is a blade installed in a DeWalt working tool. It's got 24 teeth, which connotes that it's best suited for ripping. But again, the hook angle and the bevel would help identify or highlight specifics. And so now back to the blade in our Guild working tool. It's got a 2.4 Kerf, a 20mm center bore and a 185mm rim size. And so this is the center bore. You want to do it with an Allen key if you want to change the blade. Okay, so again, that's your rim size at 185. Your center bore is at 20mm and your Kerf is at 2.4. This blade has got 24 teeth. And it's got large gullet sizes between the teeth, which means that, it can be used to move out, big chunks of wood. 24 teeth typically connotes a ripping blade, and you can see on the blade, it's highlighted that this blade is designated for cutting wood. You also have to wear your ear protection or muffins, your face mask, eye protection or safety glasses. Just pretty much take health and safety precautions. And ensure that you read the instruction manual. The National Institute of Occupational Safety and Health recommends that hearing protection must be worn when operating tools with a sound pressure level above 85 dBA or decibels noise level. And you can tell this is going to be a noisy blade because it adopts the open technology, here. The long-term goal of NIOSH is to reduce the noise-induced hearing loss in occupational settings. And so, if you want to choose a quiet blade and the appropriate hearing protection, you can check the NIOSH database for recommended sound power levels in terms of vibration of the work tool, as well as the sound power levels for the loaded and unloaded conditions of the work tool to choose the appropriate hearing protection and to estimate the noise exposure. the blade installed has got a small teeth, and the tooth configuration is an alternate top bevel. The stamped blade doesn't categorically state the hook or rake angle, neither does it state the bevel angle, but we can assume that the alternate top bevel angle is anywhere between 10 to 20 degrees typical, and that's because an alternate top bevel, which is used for all-purpose ripping and cross-cutting, typically has, a bevel angle of anywhere between 10 to 20 degrees typical. The kerf for each tooth is about 2.4 mil in thickness. And here you can see that the blade, which is usually protected by the lower blade guard, extends below the base plate. And you can see that the blade has got large gullet sizes between each tooth. The ATB, or the alternate top bevel, is suited for ripping. The 24 teeth is suited for ripping, but it essentially isn't suited for cutting strips from hard plywood. So we can see that this ripping blade has got a positive rake angle of anywhere between 0 to 20 degrees, and that's because you can see the inclination of the teeth or tooth. You can also use, a flat top grind, an alternate top bevel, or a TCG configuration for rip blades. But for hard plywood, you will be better off, getting a combination blade or a composite blade. And that's because the grain structure on your hard plywood is not uniform, it's haphazard. And so, your composite blades or your combination or general purpose blade will do a pretty good job of ripping and cross-cutting at the same time. So, what quality of cut can we expect if we proceed to utilize this ripping blade to cut strips from the hard plywood? I'd be expecting, a somewhat poor quality cut, with excessive tear out in certain places. I would also be expecting overheating, okay? So, I would be using it to get the job done, but not overly extensively, as I do not want to compromise on the integrity of the blade. I would try as much as possible to keep my hands steady, whilst cutting strips off of the hard plywood. And I will also be adding 3 mil to the depth of my cut so that the blade can cut through the hardwood plywood material at the base here. And with the open technology, around the rim of the blade, as exemplified at the base here, you should be expecting a very noisy operation of the work tool, okay? As this is not a quality blade, it is an economy blade. So just a quick recap, when you're trying to get quality cuts, the blade selection as well as the type of material that you want to cut is very important. Here we intend to get strips off of hard plywood, and so the ripping blade with latch gullets, or the open hole technology isn't the ideal blade for getting strips off of hard plywood. You should be getting a tooth configuration that's got the ATB, which is the alternate top bevel, as well as a combination composite or general purpose blade due to the grain structure of the hard plywood. In a subsequent video, I will be showing you how to use the parallel guide for cutting, sheet goods, to save time, energy, and material waste, pretty much making repetitive cuts. Here, we've got a vacuum adapter that installs into the vacuum hose. Here, them 2 screws secures the vacuum adapter onto the circular saw's fixed guard. You can use the vacuum adapter without installing the vacuum hose. That's pretty much an option, but just take cognizance that your work area will be very messy. So you might want to modify the vacuum adapter with a wood extraction adapter, which I will be showing you in a minute. So here we've got 2 G clamps. One's got a capacity of 75 mil and the other has got a capacity of 100 mil, which is the thickness that it can clamp. The 75 mil G clamp has got a throat depth of 50 mil, and the 100 mil G clamp has got a throat depth of 60 mil, which is how further in the hardwood plywood board can go in. To ensure that there isn't play when we're stripping the hardwood plywood, we will be using two clamps to secure and prevent play or movement when we're stripping the hardwood plywood. And so now, in order to prevent wood or sawdust, detritus, and wood chippings from messing up the work area, we can limit the impact of wood dust, which can be carcinogenic, from further compounding respiratory issues by wearing our safety face mask and using a universal coupling to extract majority of the debris emanating from the circular saw. At the very core level, them two couplings are the same with respect to the design, but vary dimensionally in the diameter. So the WF08 universal coupling, which is the green in the green paperback here, varies more in diameter. It's a size 40 mm, whereas the WF07 is a size 32 mm. So depending on whatever coupling fits your vacuum adapter, you can install it. Okay. Them couplings are universal. They're used in vanity wash basins, sinks, wash machines, vertical pipes and horizontal pipes. So we've just pretty much adapted this to the vacuum adapter for the circular saw, and it works perfectly fine. You might still have some sort of wood dust escaping or chippings, but majority of the debris emanating from the circular saw is captured. Okay. So here we've got the W08 40mm coupling, and here we've got the W07 32mm coupling with a tolerance of anywhere between 30 to 38mm, and you would usually find this on 1/4 inch vanity wash basins. The 40mm coupling has a tolerance level of anywhere between 38 to 48mm. And this 40mm or 1.5 inch coupling are usually found in sinks, washing machines, dishwashers, showers and baths. Okay. And since both couplings are versatile, we can adapt them, to the vacuum adapter for the circular saw. On visual inspection, the vacuum adapter fits the 40mm and 32mm couplings. We just need to torque tighten afterwards. So here I am installing the solid non-flexible hose bit into one end of the coupling. The only risk associated with installing the non-flexible bit into one end of the coupling is that when you're moving the circular saw, it could break the vacuum adapter, and that's because the non-flexible bit of the vacuum hose is static, and so that could easily yank or break the vacuum adapter, which is moderately sturdy. You can see a tiny little gap between the coupling and the non-flexible and black hose. And so we torque tighten it clockwise a little bit more to close that gap, and so that we've got a firm connection and there is no debris escaping when we're extracting the wood dust. And on visual inspection on the inside of the coupling, there isn't any gap between the coupling and the not flexible hose. So I will install the vacuum adapter on the other end, torque tighten it to make sure that I've also got a firm connection on the other side. I prefer, to install the hose, the coupling and the vacuum adapter outside of the circular saw to avert or reduce incidences of, breaking the vacuum adapter when torque tightening. That extra bit of, torque tightening the knot, when pulling on the trigger, on the drill could snap the vacuum adapter. So the last step for me usually would be to, screw in, the vacuum adapter onto the circular saw after, torque tightening, the hose and the vacuum adapter to the coupling. And also to reduce the risk of, breaking the vacuum adapter, I will remove the non-flexible hose and just fit in, the flexible part of the hose onto the coupling. So get your flathead screwdriver into the notch there and remove that clip from one end and the other clip, and that leaves you with the flexible part of the hose only. So I've kind of like push fit that into the coupling, and if I can't get it into the diameter of the coupling, I would undo it the screw, so that I get more room there, and then push fit the vacuum into the hole. Okay. And if you're not able to push fit, the flexible hose into the coupling, loosen the knot. Undo the knot anti-clockwise, step by step. You can see it's got steps in there, so you'll be hearing the clicking sound as it undoes each step. Okay. When you've got more room, push fit the flexible hose into one end of the coupling. Okay, then torque tighten it, to prevent debris from escaping, through any apertures. And you can see that the 32mm coupling provides a tight fit for the flexible hose and the vacuum adapter on the other end. With the arrow on the drill facing down, we're going to torque tighten the knot, to ensure that we've got a really tight connection between the coupling, the flexible hose, and the vacuum adapter. And if we compare the non-flexible hose against the flexible hose, we can easily see upon visual inspection that the flexible hose provides more room for flexibility when installed into the coupling. Pretty common sense. So at this stage, we're going to undo the knots, and replicate the process for the 40mm coupling. But also take note that when you're undoing the knot, on the step clip, you sometimes might undo the step clip to its full limit. So I will show you how to reset or set up the step clip to regain its full functionality. If you attempt to insert the step clip back into its aperture, it wouldn't regain functionality. The best way to do it is just to set the step clip first into position, then start torque tightening it back so that it latches onto the teeth of the step clip incrementally as you torque tighten. And so basically, when the arrow on the drill faces down, we're torque tightening, and when the arrow faces up, we're torque loosening. Okay. And here you can see that the clip teeth have started latching onto the other mating pad from the other end. So when next your clip teeth falls out of position, don't discard it. This is the way to fix it. Okay. Don't try to push it in. Set it up into position, then torque tighten gradually. Okay. And your clip teeth should come back to full functionality. So here we're replicating the process for the 40mm coupling, and you can see the force of the drill yanking the coupling and the flexible hose away, and that's what we're trying to prevent. Ideally, you don't want to be torque tightening when the vacuum adapter is already installed on the circular saw working tool. You want to be torque tightening the coupling, the flexible hose, and the vacuum adapter away from the circular saw. Installing the vacuum adapter should be the last thing that you do when you're trying to connect your hose. If your vacuum adapter connection and your flexible hose is loose, torque tighten further. But always visually inspect and test the firmness of the connection by pulling out or pushing out the flexible hose and the vacuum adapter, just to make sure that you've got a sturdy and tight fit connection. Okay, but pull on the trigger of the drill gradually and not with maximum force. And as you can see here, we've got a very sturdy connection. So the 32mm coupling works perfectly for my vacuum, which is the Henry vacuum, and the 40mm coupling also works as well. So it's pretty much up to you, whatever is your choice. Test them out and see what works for you. Okay. So here I haven't got a piece of rigid film insulation, neither have I got planks that I could stack on the floor to make diagonal cuts through the hardwood, plywood and board sheet. So I would be improvising using this rack here. You really don't need to do this, as you could employ the use of a table saw and a ripping fence, to make diagonal cuts, but I haven't got access to that at the moment. And, making diagonal cuts can be quite tricky. Okay, so I would be using this rack in place of my workbench or my table saw. Do not try this if you do not know what you're doing, okay? But resort to using your workbench or your table saw to cut diagonal cuts from your hardwood, plywood. But I'd use this because I'm quite confident that I'll be able to pull through. It's freezing and cold outside, so I couldn't stack up planks, to place the board sheet on top to provide clearance for the circular saw's blade. Don't have access to a table saw at the property, and even if I decided to use a traditional workbench, I may be able to strip off wood on the side of the workbench, but not to cut diagonal cuts, from the hardwood plywoods. And that's where, this rack comes in handy for myself, okay? The two circular poles or bars at the very top of the rack would be where the hardwood plywood board rests. The two circular bars or poles are quite ductile and malleable, so I would be clamping on the board, using my two G clamps to secure the board onto them two circular bars or poles at the very top of the rack. So the poles are quite rigid, they are firm, and sort of like just gives just about the right tension that you need to secure the board onto them poles. Suffice to say, it's not just like a rounded grip with them G clamps, at the poles. It's sort of like, a flattened out, grip, slightly flattened out grip, with them G clamps, when securing the board onto them poles, okay? A slightly flattened out grip just about where the fixed jaw and the movable jaw, intersects with the board and the pole, okay? Or the board sheet. Here, we're going to use a size 8 socket bit to fasten the mechanical fastener on the coupling. We're going to attach the vacuum adapter dust extraction bit onto the circular saw working tool. And once we've inserted the socket bit size 8 into the chuck of the drill, we fasten the mechanical fastener, on the step clip, onto the coupling. It doesn't matter, you could use whatever size coupling as long as it fits your vacuum adapter as previously highlighted, okay? As previously highlighted, the vacuum adapter goes to one end of the coupling and the hose goes into the other end. Adjust, the mechanical fastener appropriately, until you get, a tight fit, on the vacuum adapter. Once the hose and the vacuum adapter have been adequately secured onto the coupling, then you install the vacuum adapter with two screws onto the circular saw, just like I've done here, onto the fixed guard. So we have fastened the vacuum adapter onto the dust extraction outlet, onto the latches, onto the fixed guard with two screws. And prior to this, connected directly a suitable vacuum hose to the adapter. The bevel capacity of the circular saw is anywhere between 0 to 45 degrees, and to use this we need to turn the base plate bevel lock in an anti-clockwise direction to loosen the angle scale. The base plate angle scale reads anywhere between 0 to 45 degrees. Tilt the base plate away from the tool until the required cutting angle is adjusted on the angle scale, and then subsequently tighten the bevel lock by turning it in a clockwise direction. Do not use the depth of cut scale when making bevel cuts due to the possible inaccuracy. Here, the bevel cut is set at 45 degrees, and you can see that the base plate is tilted away from the tool. Suffice to say, the bevel cut capacity is anywhere between 0 to 45 degrees. You can cut 0 degrees, 15 degrees, 30 degrees, and 45 degrees on the bevel, okay? So basically just undo the bevel lock anti-clockwise, toggle through the angles that, meets your bespoke requirements, then, to turn the bevel lock clockwise to secure or confirm the angle that you want to, cut through. And for the depth of cut, if we lift the lower guard lever to reveal the lower blade guard, it reveals the blade, and when we visually inspect the blade, we can see that the blade is too far out, from the base plate. And that's because we do not need all of that, blade protruding from the base plate if we're just cutting, a hardwood plywood of about 12 mil. And here you can see that, the blade protrudes from the base plate, so the depth of cut is definitely greater than 12 mil, which is the hardwood plywood's thickness that we want to cut through. To reduce the depth of cut to 12mm or 15mm, we lift the depth of cut lock lever and raise the saw body away from the base plate. And straight away on visual inspection, we can see that the depth of cut skill's limit is up to 65mm. Okay, that's the upper threshold value range. Okay, so what we want to do is to set the depth of cut with the scale to about 12mm, which is the thickness of the hardwood plywood that we want to cut. Okay, best practice would be to always add 3mm to the depth of cut so that the blade can comfortably cut through the material. So although we want to cut 12mm on the hardwood plywood, we will be adding 3mm to the 12mm, which gives us 15mm, okay, so that the saw blade can easily cut through the hardwood plywood. Okay, and so here I will be reducing the maximum degree from 65 to about 15 degrees on the scale. And so this is what 15 degrees looks like. Initially it was 65 degrees, and you can see that it's got too much clearance. So I'm going to reduce that to 15 degrees on the scale. And once it's 15 degrees on the scale, I will push down the lever down to lock in position. And so the cutting capacity for the blade at 90 degrees is 65mm, and if you have the cutting angle to 45 degrees, it can only cut up to 45mm. Suffice to say, if you set the depth of cut to 65mm on the scale, it would provide a cutting capacity clearance of 65mm below the base plate at 90 degrees. 45mm on the scale will yield a cutting capacity clearance of 45mm below the base plate, and at 0mm the cutting capacity below the base plate is significantly reduced. And so basically we have set the depth of cut in line with the thickness of the hardwood plywood that we want to cut. If you don't know the thickness of the material that you want to cut, just set, the blade beside the thickness of the material directly, just underneath the base plate, and then subsequently adjust the depth of cut scale accordingly. And once you have set the depth of cut, just slightly beneath the thickness of the material, push the lever down to lock the depth of cut into position. Before you proceed with this operation, make sure that you're wearing the appropriate safety glasses, an approved face mask, and ear protection. For health and safety reasons, you don't want damage to your hearing, you don't want respiratory issues, or getting carcinogens into your respiratory tract. So protect your eyes from foreign object debris. Health and safety is very important. The next step of the process would be to carry out a risk assessment with regards to slip and trips, where you've got, one side of your vacuum connected and, the other side where you've got, the circular saw connected. Make sure that you've got enough clearance when you're moving. And you can also see that the vacuum hose is on the right. So halfway through the cut, I'd have to adjust so that the vacuum hose doesn't get in the way. And here you can see the working tool or the circular saw's connection point. To prevent the movement of the rack when cutting, and to allow, for clearance when I'm done with the cut, so that the circular saw can exit the end of the cut easily, I have wedged the rack with a chair against the door. You can wedge it with an object of your choice that provides, impediment or, movement of the rack when cutting. You don't have to do this, we're just improvising here, okay? Make sure that the good side of your plywood is facing downwards, as, the circular saw cuts in the upward stroke. And so it is more likely that you'd get the rougher bits on the underside or the bottom side as opposed to the top side. The next step of the process would be to cut in line with the markings on the underside. Set the base plate of the working tool on the underside of the plywood, right at the lines of the markings. Get the saw blade spinning right before it engages the plywood, whilst the base plate, is sat flush on the underside of the plywood. Do not start the working tool right where the saw blade engages the wood. Always hold your saw firmly with both hands when operating. You need steady hands when trying to cut through the hardwood plywood. Your switch is locked off to prevent accidental starting. Your working tool has got a safety on and off switch. Firstly, depress the lock off button and then subsequently depress the on and off switch. After depressing the on and off switch, release your hands from the lock off button. The switch is now on from here onwards. To switch off, just release your hands from the on and off switch. The blade may continue to rotate after switching up, so just wait until the tool comes to a complete stop before setting down the work tool. Ensure that the saw blade is not in the way of the cord or wire and that you're slightly offset, from the working tool when cutting through the plywood. The most probable root cause of why the saw blade has stalled or binded is because it has deviated from its line of cut or wavered during the cutting process. Suffice to say, cutting at an angle. Or it could be that, the work tool was leaning on either side of the cut work pieces, where we were trying to make diagonal cuts, thereby cutting binding. If this happens, do not pull the work tool, from the wood piece. As earlier highlighted, just release your hands from the on and off switch. Like I said, the blade may continue to rotate after switching off. Just pretty much wait until the tool comes to a complete halt or stop before setting down, okay? After which, you can reposition, the working tool, along its line of travel or linear travel, okay, ensuring that the blade doesn't rest on the wood and it's free spinning, whilst you're trying to retrace its line of travel. You can start at, at the very initial position where you started making your diagonal cuts, or you can start off at the position where the saw blade stalled, but if you're experiencing difficulties from the stalled position, you can start from the initial position and retrace your line of travel all the way through whilst making your diagonal cuts. So I will replicate the process of cutting through your plywood when you're halfway through. So here you can see that I'm providing enough room for the saw blade to spin prior to cutting halfway through the plywood. At this stage, I have ascertained that the blade isn't angled and it's free spinning, so I'll proceed to finish off the cut, as I am pretty confident that the saw blade would not be latching or cutting into the sandwiched sides of the hardwood plywood. Just make sure there's enough room and it's not picking on the sides of the plywood before you proceed to finish off your cut through the cut line. This is the first cut, and it's not an entirely smooth, fine quality cut, but at least we know what our do and don'ts are. And please do note that other less probable kickback causes could result from overheating, which causes the blade to warp, blade dullness and unguided cuts, sap build up in the blade, and lastly, incorrect blade height. So let's visually inspect, the diagonal cuts to see if we've got, fine quality cuts. And straight off, you can see that, it's not a very fine or pristine quality cut. And, there are a host of reasons why this has happened. Firstly, you can see that, the blade bent at an angle. We kind of wiggled and, we didn't accurately have a continuous cut. It wasn't a linear cut. And as such, the blade binded in the sandwiched edges of the plywood. Secondly, the blade selection isn't spot on, okay? We have selected a ripping blade here, which is much suited for ripping applications as opposed to applications for veneers like your plywood. A combination or general purpose blade would have been more suited for your hardwood plywood, as cutting or making diagonal cuts on the plywood involves ripping and cross-cutting at the same time as you cut through its line of travel. Click on the link in the description or at an earlier part in the video where I kind of like discussed, blade selection with respect to your hook angle, your bevel, the number of teeth, the tooth configuration, and what blade is suited for what material, okay? The next step of the process would be to repeat and reproduce the process, replicate the process, not that we know exactly what we're doing, to get, finer quality cuts from the ripping blade. A workman is only as good as his tools, but we're just going to try and get, good quality cuts from the ripping blade. But, if we wanted optimal quality cuts, then, your combination blade or your general purpose blade, is the way to go, as they are capable of producing the finer quality cuts that you see on the side of the hardwood plywood. So we are going to make more diagonal cuts, but ensuring that, our hands are sturdy, we're not deviating from the cut line or the line of cuts, we're not wiggling, we're not, putting pressure, of the work tool onto the material that's being supported by the poles of the rack, whilst ensuring that our saw blade spins freely before it engages the hardwood plywood, and if possible, engineer a continuous cut. So the next step of the process would be to replicate and run the saw blade through each subsequent work piece line of travel. And as you can see, this is a much better cut. So we're going to replicate the process again and cut this hardwood plywood into 4 pieces diagonally, from both ends. Reclamp subsequently and replicate the process on the half cut plywood hardboard. And like I said previously, make good use of your safety lock-off button, okay, to prevent accidental starting. And when ready, press on the switch or the trigger. Make sure that, the saw blade has enough room before it starts, cutting through the wood. And cut linearly, continuously along its line of travel, or along the pencil mark that you've lined up on the hardwood plywood. The next step would be to rework the plywood hardwood piece where we had, the binding or the kickback from the work tool. Just strip off, the side to get a finer quality cut with the circular saw. And trust me, this stripped off bit is not the best looking piece on camera, but it looks a lot better, in person when you actually visually inspect, the stripped off piece. And as you can see, it's not the best looking quality cut, aesthetically, but it's better off than the binded cut that we had previously. At best, the blade has just done is slightly below par of medium cross-cutting and ripping, of the hardwood plywood. A combination or general purpose blade would have done a much better job with respect to getting quality cuts. Once done, place the working tool on its underside. Despite the fact that we've got a lower blade guard to protect the blade, you don't always want to be placing a working tool where you've got the blade, because that could damage the blade accidentally. Okay, you can store the coupling away or leave it installed on the vacuum adapter. Okay, provided you haven't got the hose on it, that's fine if you regularly use your circular saw. But if you don't, just store the coupling away on its own or as a standalone from the circular saw. Then subsequently disassemble the coupling from the vacuum adapter by undoing them knots. And whilst undoing them knots, if the clips on the coupling, disengage fully, bring them quite close to each other and tuck tighten the screw, and the clip should get back into position. If you do not have a table saw, you could deploy the use of a parallel guide or a rip fence to make repetitive, accurate, long, lengthy cuts. The parallel guide rides along the edge of the plywood. The parallel guide has got a scale on it that helps you determine the size of the plywood that you'd want to cut, strip or rip through. It's also got a lock knob that helps you lock the parallel guide into position. And once we've worked out the width of the strip that we want to rip, we can proceed to lock out the lock knob. A rip, fence or parallel guide will only make accurate cuts, provided the edge of the plywood board is straight to begin with. And then subsequently, I will be marking out, the cutting line for the strip, as saw blades are particularly very good at making linear cuts. Okay, so this is a secondary aid outside of the rip fence to help guide during the stripping process or ripping process. The rip fence or the parallel guide can be used from both sides of the base plate, so I'll show you what I mean here. So you can see the rip fence on the right hand side, or at the 3 o'clock position from the base plate. The rip fence has also got a scale on it which helps to determine the rip width. The rip fence has got an interchangeability capability, which essentially means that if you're cutting from the 9 o'clock position, which is to the left of the saw blade, you can undo the lock knob and switch the rip fence, or swap it around to the 9 o'clock position or to the left hand side of the saw blade, and then subsequently lock out the parallel guide and lock knob to key in the rip fence into position. Irrespective of which side of the board you're cutting, if the edge of the board is curved or warped, then your rip cut will be off by the same amount as the edge of your board. So I can stress it enough, the edge or the side of your board should be as flush as possible, against the rip fence or the parallel guide. This parallel guide enables you to make narrow rip cuts, but if you want lengthier or larger rips, you could deploy the use of a parallel guide extension. So here I have taken cognizance of the fact that the plywood has been clamped onto the workbench. The edge of the plywood is flat, it's flush and it's straight. The lock knob has been locked into position after deciding the width of the rip, and I have also provided clearance for the blade to spin prior to latching onto the plywood. The cutting line has been marked onto the plywood as an extra pair of eyes to enable a more accurate cut when using the ripping fence or the parallel guide. Suffice to say, for linear cuts, deploy the use of a circular saw, and for non-linear cuts, deploy the use of a jigsaw. This 24 teeth blade is more suited for ripping applications in natural wood. A special purpose designated blade or a combination or combo blade will be better suited for cutting plywood, as plywood is a man-made wood and not a natural wood. And so if I use the 24 teeth open technology blade to cut my plywood, it might, get the job done, but I risk overheating the blade and damaging the blade, so I will not be using it in this video. But subsequently I'll be showing you how to use a combo blade or a special designated blade to cut or rip plywood. Okay, as plywood encompasses a mismatch of grain structure, so you have got grains across the grain structure and along the grain structure. So it's important, to get quality cuts, you need to take into account the blade selection and the type of material that you're cutting through. Click on the link in the description, for blade selection. It's a whole dossier of things that you should consider when selecting your blade. Okay, and for a simulation of how the blade impacts or cuts through the plywood, let's revert back to the initial highlights of making diagonal cuts with the circular saw. The only difference is that in this case we've just included or retrofitted the rip fence or the parallel guide to enable us make accurate cuts, as opposed to just doing it freehand with the cutting line. And this is what I mean here, freehand with respect to in relation to the cutting line when you're making diagonal cuts. Okay, so basically when making diagonal cuts, it's basically the same process. You're making linear cuts without the use of the rip fence or the parallel guide, and that's because you can't fit it in between the midsection, as opposed to the edge of the plywood board, which provides clearance for us to install the rip fence or the parallel guide to enable me to make repetitive, accurate linear cuts. And one more thing, whilst cutting through the wood linearly, if you stop halfway because you need to adjust your position, make sure that you do not take the circular saw from its line of travel or from the cutting path. Just switch off the working tool, and when you're ready to continue, just proceed from where you left off. Also try to make sure that the blade is free spinning and it's not catching onto the wood before you proceed. Okay, and as previously highlighted in the video, if it catches onto the wood before it moves on, then you might experience binding or kickback. Okay, click on the link in the description for useful links on how to set up your circular saw working tool and how to select your blade when cutting certain materials. And that's about it really. If you found the information in this video useful, don't forget to subscribe, like and share. Helps the channel grow, and hopefully catch up with you later. Goodbye.